So in this example, is not plus, is not minus, and we cannot come up with a formula. But what we can do, we can say this multiply by this one, it gets 0. That means log of 6x plus 43 must be 0, or log of 9x squared should be 0. Agree? Same as factoring. We use the quadratic. For example, we factor it, and they said this should be 0, or that one should be 0, and we solve it. So in this case, only when you see multiplication between two logs, you make the first one 0. So now we have a single log. So we do have a single log, which we use this property. So can you tell me log of 6x plus 43 equal to 0? How do we solve for x? Log of what number is 0? Lucas.
Log of 1.
Beautiful. So in your note sheet, you have log of 1 to any base equal to 0. ln of 1 equal to 0. Correct? Let's say you don't know that. Let's say you forgot about 1. So what we do, when we have a single log, we make it to exponential. This is my a, b is 10, and this is c. That means 6x plus 43 should be 10 to power of 0. What is 10 to power of 0? Is 1. So 6x plus 43 equal to 1, and you solve for x. Correct? So when, again, we're dealing with log, we make it to a single log, then you make it to exponential. We have to get rid of the log in order to solve. So right now, 6x plus 43 equal to 1. We're going to solve for this x. So minus 43 minus 43. 6x equal to negative 42 divided by 6. X equal to negative 7. All right. So now let's work on the next one. So making it to exponential is a good one. Or you can say, oh, this should be 1 in order that log of that equal to 0. But I don't recommend it. When you make a single log, apply the exponential. You're going to say 9x squared equal to 10 to power 0. 9x squared equal to 1. X squared equal to 1 over 9. Correct, Ella? Now, how do you solve for x here? X squared equal to 1 over 9. What is x?
You have to square root both sides.
Very nice. So x will be plus minus 1/3. All right. Now, in order to put this in the computer, I mean, I cannot do anything, but usually they ask you guys, put it in increasing order. So you need to, so we got negative 7. I put negative 7 first, then I put negative 1/3, and then I put positive 1/3. If you rearrange them, it's not going to work. All right. What's your next question?
5.177.
5.177. I think I solved this in one of the videos, but let's go over it again. They said solve. Again, you're going to solve for x. They said exactly. Exactly means no calculator. Exactly means you need to rely on your note sheet. page of the formula sheet that you have. And it's not that much, correct? So we have 2e to power of 3x plus 2e to power 3x equal to 1. We are looking for this x. I mean, definitely, I mean, if I ask this question from a person who has like a PhD, they're not gonna just jump to it and solve it. They're gonna back up a little. They have to understand, you have to understand the equation, right? Don't feel bad if you spend 20 or 40 minutes. That's normal. And we see that this is not linear. This is not quadratic. So that means we have little challenging. You have to use little of your skill. Because if that was a quadratic, there is a formula for it, quadratic formula. If that was a linear, there is a steps to solve it. But now we're dealing with random function and has exponential. So we're gonna collect that this is e to power 3 of x, this is e to power of 3 of x. So after looking at 10 minutes, we're gonna see, oh, we can combine them. They're exactly the same. I will get 4 e to power 3x equal to 1. Correct? I am looking for this x. So that means x has to be by itself somewhere and everything else the other side. So I'm not going to make any mistake. So this is a 4. I'm going to divide it by 4. I'm going to divide it by 4. Again, so far, I'm eliminating numbers, the part that x has, e to power of 3x equal to 1 over 4. So can I, what else can I do? Can I divide by 3? Can I, the power of 1/3, does it help?
You have to move 3x. to
How
the
do I
other
move the
side.
3x?
ln, I think.
Very nice. That's great. So this is a skill. I mean, when you are here, when you look at the equation, so we did all the basic algebra here. We combine them, divided by coefficient. Now, even if you divide it by 3, that would be wrong. I mean, that's something that I know you don't feel to dividing by 3, or dividing by e, or something that doesn't make sense. At this point, because the unknown we are looking for, the x that we are looking for is exponents, and you learn about exponential function. In order to solve the exponential, we can take a log of both sides, or natural log, or make them same base if it's possible. We love making the same base because we get exact form, we get exact number. Log and natural log gives us all decimal, correct? So first we will try to see if we can make this base equal to that base. And it's impossible. What we do when we learn if there is an e in the equation, we use ln. So I'm going to take a natural log ln here and ln there. So now I apply exponent. This is going to come over front of ln. It will be 3x ln of e equal to ln of 1 over 4. Ln of e is 1. You should know that. So we have 3x equal to ln of 1 over 4 divided by 3. Then we are done. So x equal to x equal to 1/3 ln of 1 over 4.
So on the homework, I got ln of 1, but does that cancel further, or do you just
So
leave
how did
it?
you get ln of 1? So we had 3x ln of e equal to ln of 1 over 4. Then what? Now here's a problem. You said you see a 1 here.
Oh, because the question is different. Like it's not the one on the homework. It doesn't have the 2 in front of it. So when I solved it, I got ln of 1.
Do you know what was your question? What was your equation?
Or like the question, or what I got as my answer.
No, the question. I mean, my
It
question.
was e. Yeah, it was e to the 3x plus e to the 3x equals 1.
Okay. So here we combine them, you get 2, right?
So when you combine them, you get 2. Like, so there's like an imaginary 1.
Excellent. Yeah.
Okay.
Same as I asked you, what is a plus a? We get 2a.
Mm-hmm.
So yeah, there's an imaginary 1 here. Yeah. Even we just combining like term. We have 1 e to the power of x. So this term is exactly like this term. So if you get same thing, we're gonna say 2 of the same term equal to 1. Then you divide. You don't take ln here. I divide by 2. Now we have e to the power 3x equal to 1/2. Now I take ln. Take ln. Are you following me? So now the exponent comes here. We get 3x ln of e equal to ln of 0.5. Instead of 1/2, I put 0.5. ln of e is 1. Then x will be 1/3 ln of 0.5. Or ln of 0.5 divided by 3. If they said exact, you leave it like this. All right?
Yeah, I got it.
Did you solve the second part of this?
Yes, I got the second part right.
You got the second part, but I also solved it in one of those YouTube things. What other question you have?
This one's on the practice test.
Okay,
It's like the last question, like the very last question.
sure. Practice exam 2. You really don't like log. There's another log question. So again, solve. No calculator, that means exactly. The question is log x minus 4 plus log x minus 2 equal to log 24. All right. So what do we know that we can apply here? So we said when we have a log, the idea is we need to apply all the properties to make it to a single log. When we make it to a single log, then we make it to exponential. Good? There's no way we can just plug number here to solve it. We have to combine it. So can I combine these two?
Are you going to multiply them together?
Yes, so there is a property that if there is a log of A plus log of B, you can write one log and multiply the inside. So this is, we have a log, there's a log, there's no number here, correct? This is exactly the same as this formula. This is going to be A, that's going to be B. So I'm going to write one log and multiply x minus 4 times x minus 2. equal to, that's equal to log of 24. All right. Now what should we do? Benas, what should we do?
Are you gonna multiply them out?
Multiply this one? Yeah, but
Yes.
we have to somehow
Are
don't
you
have
gonna
to.
get rid of the logs?
Can I just cancel log both sides?
No, you're gonna do the property thing.
What
What's that?
property?
Where it's like a to the b power equals c.
So yeah, that's the main property log of a, not the b power, log of a base b equal to c, a equal to b to power of c, correct? But do I have any, if we had this log over here and other side was a number would be good. But now what we have is a 2 logs. Lucas, what do you think?
I'm not actually sure on this one.
Okay, so there are 2 ways we can solve this one. I can bring the negative, I can subtract log of 24, oh my God, log of 24 from both sides. I'm gonna get log of x minus 4 times x minus 2 minus log of 24 equal to 0, correct? Now we have 2 logs, the minus between them, we apply the division property. We write one of the log, x minus 4, x minus 2, divided by 24 equal to 0. So now we made it to a single log. Correct, Benas? Now we have a single log. Now we can apply the rule you were saying, ABC. Now we can say this, which is A, B is 10, and that is C. We're going to say x minus 4, x minus 2 over 24 equal to 10 to power 0, which is 1. So we get rid of the log. Good. We get rid of the log, so we should be able to solve. The scary part is gone. So now we're gonna have, we're gonna have, why my color is exactly the same color? We're gonna have x minus 4, x minus 2 equal to 24. So I cross multiply. All right, Ella? Good. So how do I solve for x? Is that linear, that quadratic?
It's quadratic.
Quadratic. But I can, this is in factor form. Great, we love it. But the other side should be 0. It's not 0. That means we need to distribute this one. Bring 24 the other side, make it 0, and then factor it. So we're going to get x squared minus 2x minus 4x plus 8 by x times x is x squared, negative 2x, negative 4x, positive 8 equal to 24. We have x squared minus 6x. I combine these two, I get 6x minus 24. If you subtract 24 from both sides, we will get minus 16 equal to 0. So we got an equation that we love, and we have a method to solve it. Quadratic formula or factoring. Can I factor this?
Yes.
Ella, can I factor this?
Yes.
What are the factor?
X minus 8, x plus 2.
Very nice. X minus 8, x plus 2 equal to 0. I get my x equal to 8, x equal to negative 2. Let's see if I can charge my. All right, yeah, hopefully it works with 5%. So we got two solutions. Are we done with this? No, you're in pre-calculus course. I mean, you need to do more work. So let's go back all the way to beginning. Here, I'm gonna go, that was a question, correct? For the log, I mean, we did algebraically, we didn't do anything wrong. We solved it. Because we applied the property of log, we went to the quadratic, we factored it, we solved the quadratic, x equal to 8 and x equal to 2. But then for the quadratic, for logarithm, you need to check the solution. You have to plug it back to see if it works or not. So right now, if I put 2, if I put 8, they said x equal to 8, correct? X equal to 8. If I put 8 here and 8 over there, let's see if I get log of 24. Don't think we're doing too much work. That's fun. You have to make sure we get the point. So we're gonna get log of 8 minus 4 plus log of 8 minus 2. Log of 4 plus log of 6. Bernard, is that log of 4 plus log of 6 equal to log of 24?
Yes,
How did you get 24?
because you multiply them together.
Very nice. Yeah. Ella, correct. This is plus. You write one of the log, you multiply them, you get 24. Now, if you plug negative 2, is negative 2 going to work?
No,
Why?
because you don't get log of 24. Because it's negative.
Ella, the negative 2 works? If I plug negative
No.
2, I want to put negative 2 here, correct? This will be negative 4, and this will be negative 6. Negative 6 times negative 4, what is that? Positive 24. But we don't accept negative 2. Why? Because our lovely log, this log, never accept negative number. Has to be positive. Here, if you plug negative 2, we get negative 2 minus 4. Minus 2 is negative 4. Log of negative 4 over there will go crazy. I mean, they will go. So that's not going to work. So we don't accept negative 2. We only accept x equal to 8. So you do extra work when you got the solutions. All right.
I don't really understand like the 10 to the 0 part. So does the 10 to the 0 just like cancel out each other?
So here, correct?
Yeah.
So the first formula that we learn, so the idea is in order to solve the log, we're gonna use log of a, b equal to c, then a equal to b to power of c. So I'm gonna apply this formula. This is my a, this is b, and that's c. So x minus 4 times x minus 2 divided by 24 equal to a equal to 10 to power of 0. 10 to power of 0 is 1. If you use a calculator, 10 to power of 0 gives you 1. So that means this is 1. Then you cross multiply, we get what we solve. So just for your information, there is a shortcut to do it. Only for this particular question, only for this one. If you see an equal sign, only one log here and one log the other side, only single log this one, single log over there, you can just get rid of it. You can just, not dividing them, there's an algebraic way to do it, but you can just cancel it. Only in this case. If there's a one log, you just cancel it. All right? You don't need to subtract it, apply division. But at this point will be same. I mean, you will get you get this one equal to 24, then you FOIL it, you will get the same answer. Any other question?
Those are all my questions, I think. Yeah.
Okay. Lucas, Benaz, if you guys have questions. Jenny, Katie, Michelle. Any
I
questions?
finished homework number 6. I just had 2 questions.
Okay, what is that?
The first one is, here, give me 1 second.
Sure.
Okay, the first one is section 5.1, question 35, part B.
Okay, you are in homework. Okay, let me go to homework 6.
Yeah.
Homework 6. What number?
It's section 5.1, question 35, part B.
All right. We have 100 for log x to power of 4. That's what I have. Is it similar to what you have?
Yeah, I have 1,000. 1,000 for log x to power of 3.
Okay. So let's solve both of them. So it looks kind of strange, right? It looks like a super complicated one. But if you look at in your note sheet about the property of log, only one of them has like a to the power of log of x base a. The only one of them has log as an exponent. We have addition makes it to multiplication, subtraction makes it to division. Then the first one, ABC, make it to a equal to b to power of c. Only one of them has log on the top, which this one is log on the top, correct?
Yeah.
So let's see if we can apply that formula. So this is a formula that means, again, if you have a number to the power of something, the same number, these two are same, then the answer is x. Then this will be here. Example 5 to the power of log of 2 base 5. If these two are same, the answer is 2. Good, that's the story. I mean, if I were you guys, I'll put that formula and make few example. So this is 100. What is the base of this log?
10.
So this is a good news. If instead of 100 we had 10, that would be
Squared.
Correct. Very good. So that's what we need to do.
Yeah.
Before we make the 100 base 10, we have to get rid of this coefficient, this number here. How do I get rid of that?
Can you put it in front? Or?
No, it's already in the front. Oh, you want to move this 4 over here?
Move it. Okay, yeah.
I'm going to go back because the formula here, there's only one. There's
Yeah.
no number there. So the formula, if you have m log of a, this is log of a to exponent m. So I'm going to rewrite this one. 100, we didn't touch. We have log x to the power 4. We added this to the power of another 4. If this bothers you, bring it over here, anywhere you
Okay.
like. What is x to the power of 4 to the power of 4?
X to the power 16.
Very nice. So we're going to get 100 log x to the power of 16. Now what should we do?
Now we take make that 10 squared.
Very good. So we don't want to make any algebraic mistake. It's like a brain surgery here.
Yeah.
This is 100. Instead of 100, I can put 10 squared, correct? I put this
Yeah.
inside of a parenthesis, and I put whatever we had before here, log of x to the power of 16. What should I do to this exponent and that exponent and this exponent?
Can you multiply them?
Yeah, same thing you did. Don't scare. Log of x to the power 16 is a number. So
Yeah.
we multiply them by color orange. So this will be 10. If I multiply this by that, it will be 2 log of x to the power of 16. All right, Ella? Now what should I do? Make little room.
Are you gonna move the 2 to the front of the equation?
Yeah.
Very good. The formula that we're going to use, there is no number here. So this, what did you say, Venus? Front or?
I mean, to the 16, multiply it by the
It's
16.
going to go there, right? So we're going to have 10 log x to the power 32. Good. X to the power 16 to the power of 2 gives x. Now what should I do? Now the base is 10,
Don't-
correct? This is, and that one are same. We apply the one of the formula. This guy will fill here 32. So it's x to the power 32.
Okay.
So you have same thing with 1000.
Yeah.
So move this one over here, correct? It will be x
Yeah.
to the power 12.
Yeah.
This will be 10 to the power of 3.
3.
To power of log of x to the power 12. 3 gonna go there, then gonna go there, gonna be x to the power 36.
Got it. Okay. And then my second question was section 5.2, question
Uh-huh.
4.
All right, very good question. I need water, that's all. So we are dealing with chapter 5, section 5.2, question 004.
Yeah.
They're saying convert Q equal to 84 e to power negative 0.14t to Q equal to A b to power of t. That means we need to solve for A and we need to solve for B. Correct, Lucas? That's what we need to do. So we make them, I would make them under each other. I will make Q 84 E negative 0.14. I put the T outside.
Okay.
And then Q A B to power of T. What do you think A will be?
84.
So this T and that T are same, correct?
Yeah.
So there's no way you can break that one down to, you cannot think about that, oh, probably I can pull something out to give it to 84. No. This T dominate this base. That means the base of that T, this is a T, and that's the base. So for sure, this should be equal to that, and A should be that.
Yeah.
Agree? So that's a good vision. So I'm going to say A equal to 84. I'm positive. Done. Now B equal to E to power negative 0.14. If you plug that over there, I know B equal to that, but most likely they ask you guys make it to decimal form, correct? If you said exact, so you leave it like this.
Okay.
But if you leave it like this, you get same thing back.
Yeah.
So the B, that means you have to get rid of E. Good.
Do you have to take ln to get rid of
Now,
E?
so I'm gonna make them. So this is B, correct?
Yeah.
Why you want to take E? Why do you want to take?
Oh,
ln?
no. Do you set? Sorry. Do you?
Ella, what do we do?
What are we solving for again? T or B?
V.
Do you you move the negative 0.14
Where?
to the front? And then
We
multiply
do
it?
that if I take a ln, correct?
Yeah.
If we had ln, do I need to take a ln here?
Do you just put it into your calculator as is?
Yes. Yeah. Very nice.
Okay.
We took ln if there's an unknown here, correct? If there's an x here or t there, we take a natural log to bring it down. But in this case, there's nothing there. If we have
Okay.
b equal to this, so use the calculator and plug it there.
Got it. Okay. That was much more simple than I thought it was.
All right.
Thanks for your help.
No problem. Bena's question.
Yeah, can we go over, it's the forgot what it's called, the practice exam, section 5.3 skills refresher, question 7.
Let me get to that page and then practice exam 2. So you guys need to take the exam soon, correct? You know,
I
you have
already
to
took
take,
it, but
oh, you took it
this
already?
one, yeah, but this one I got wrong, and I wanted to like know why.
Which one? What number was it?
The skills refresher, question 7 for section 5.3.
5 point. So now people who didn't take the exam, pay attention here. We have natural log x 8 minus x squared. They ask us to make it to sum or difference. Correct? This is a single ln. One of the questions, I mean, I solved this one. One of the questions that you see in this chapter, I give you few logs and ask you guys make it to a single log, or I give you a single log and ask you guys to expand it. So here is a multiplication. If we have ln of a times b, I write ln of a plus ln of b. So I'm going to write ln of x plus ln of 8 minus x squared. Are we done with this one, or we can do more, Benas?
Can you do more?
Like what? What else should I do here?
Well, I don't know, because I
Well,
put an
I mean,
A
this 2 can go over here. It will be ln of x plus 2 ln of 8 minus x. Now we cannot do anything. We made it to sum.
So the x in the first part, can you not like, you're not supposed to distribute it out. You just like leave it and separate it.
Oh. Ooh. Okay. If you, can I multiply this in, did you multiply it inside?
Yeah, I did that the first time, and then the second time I got it. I was like confused.
No, if you know there's a 2 here. If we didn't have this exponent, you're right, we would distribute it. But still, we don't want to make, I mean, for the single ln or single log, we would like to have it in multiplication and division because there's a formula for it. So I cannot distribute the x inside of the parenthesis because there's an exponent here. If you apply the exponent to this, you're going to get 64 minus 16x plus x squared, correct? If you FOIL this one. And there's x here. And you're gonna, if you want to multiply this inside, it would be not a good idea because there is no formula for addition and subtraction. Did I confuse you? Benas?
Is that the final answer?
This is the final answer. We made it to addition.
Okay, because I thought it said there shouldn't be any logarithmic expressions in the answer.
What? No, what I see here, they said, if possible, write the expression this using sum and difference of logarithm expression that do not contain the logarithms of the products. So they should not be products or quotients or power.
Oh, okay. That makes sense.
Addition and subtraction is okay. Yeah, the way the sentence said, they said should
Okay.
not contain the logarithm of products. I mean, this is a logarithm of products, correct? They said
Okay, I thought it meant you had to get rid of the ln.
we don't, we cannot.
Okay.
There's no way we can get rid of the ln. They give you, so you, the way the question asking, you're confused about, they didn't ask you get rid of the ln. They ask you write it in terms of addition or subtraction. And they said your answer should not have any logarithm of products or division or the exponents. So we get rid of the exponents here and we get rid of the multiplication there. Same question, ln of x plus 5 multiplied by x squared minus 2 divided by x cubed. This is a single ln, correct? Has product and has division. My question is get rid of, so write it in sum and difference. So write it in sum and difference. And at the same time, I can add extra hint, get rid of the exponents, division, and multiplication. So what I do, so here's a multiplication. I'm going to write ln of x plus 5 plus ln of x squared minus 2, correct? Multiplication going to be to addition minus ln of x cubed. So ln of x plus 5 plus ln of x squared minus 2 minus the 3 going to go here, 3 ln of x. So if we have ln, maybe if you make it to product, you will get back to this one. All right. All right, Bernaz.
Yeah, that makes sense. Thank you.
Any other question?
Oh, no, that's the only one.
Anybody else? All right, guys, have a good evening.